Problem number 13. 13 is kind of it's a division problem here. And we haven't done a division really that's just like this one. But you'll see he is actually pretty easy to deal with here. See if I can get my pen setting correctly there. Still not. Anyway, so if you take a look at it, it says simplify this basically fraction. That's what we've got there, just a fraction. And you can't simplify like individually, like you can't go 5 and 10 and just simplify that, because you got to take, it says, hey, divide this by the 10x and this by the 10x. And there's a couple of ways to do it, but probably the easiest way, since this is just a single monomial, this is like having common denominators but unsubtracting them. So this is the same problem. Okay, we've just separated them, so instead of saying, hey, they have common denominators so we can subtract them, we'll just leave them like these separate things like this. And what that allows us to do then, since this is just, all multiplication on top, all multiplication on the bottom, we can just simplify that fraction. And so like 5 over 10, you can see that goes to 1/2. And you got an x squared over an x. So again, that's like your x to the second power. You're subtracting the 1. The exponent on that denominator is just 1. So you get 2 minus 1. You just get a single x on top, which you could write as 1/2 x, or you could write as just x over 2. Those two things mean the same thing. It's a sloppy looking x over 2 right there. Okay. Let's look at that the second term up here simplifies too. So here you can see the x's would just cancel, and 15 and 10 are both divisible by 5, so this becomes minus a divide by 5, 3 over 2. So minus 3 over 2. So x over 2 minus 3 halves, something like that. But these both have common denominators, so this could also be just written as x minus 3 over 2 that way. Which brings us to a different way you could have handled this original problem to begin with. And this is kind of the way we usually do it. Take your numerator and just factor it. So you can see they have a common 5 you can take out and an x. We just talked about GCFs earlier in the handout. So if I take a 5x out of just the numerator, it leaves me with x minus 3. Remember, you could always redistribute just to check. 5x times x is 5x squared, and 5x times negative 3 is negative 15x. Okay, so it's still the same thing as the numerator, just in its factored form. And then the denominator, you don't have to factor, but I'm going to rewrite it as a factorization. So it's like 5x times 2. That's still 10x. But then you can see the 5x cancels the 5x, and so we get the exact same answer. So x minus 3 over 2, factor that numerator, and then just see if you can cancel the factor with anything in the denominator. Now there is one caveat here. X could not equal 0, even though it cancels out, since x was in the original problem. We aren't asked about domain or anything in this situation, so that would be just fine.